So yeah, this is problem number 9 of the MIT Integration B qualifying exam 2017, which is the indefinite integral of sine of square root of x. So this is a simple problem, but to me, I look at this function. It's very interesting, and that's how I kind of find it as a very fascinating problem. And we'll look at the fascinating aspect of the function, but obviously we'll also solve the problem at the end of it all. Okay, so let's jump into it. So this is our problem, right? Sine of the square root of x. So let's look at the integrand and look at that function. I'll begin first of all by looking at how does the plot of the square root of x look like in the xy plane. So it's going to, so xy, I mean the square root of x is going to be like that, and then we assume that we focus on real functions here and real values. And then if we have equally spaced values on the x, definitely the deltas in the y corresponding to this deltas in y is going to decrease as you go higher and higher in the x domain. What that means for us is that the sine of the square root of x is, you're going to have a signal like that, and the period with respect to x is going to increase, right? And in the field of communication, we say this is a chopped signal, right? A signal whose frequency or periodicity increases with time or decreases with time. We have what we call an up chop or a down chop, right? Since we're not dealing with the time aspect of things here, let's come back to our integration. Sorry for that distraction, but some of the things are necessary as we learn. So what I would do is I would say let u be equal to the square root of x, and now what it means is u squared is equals to x, and we would say 2 du dx equals to 1, and so we would substitute for dx with 2u du. Okay, now what happens? So if we have that, and we say that this is going to be u and this is going to be 2u du, so this integral becomes sine of u, sorry, I went too quick there, but sine of u and 2u du. Okay, so this is, if I pull the 2 out, we have 2 the integral of u sine u du, and sine u is same as the derivative of negative cosine u, right? And if we use integration by parts, where we say if we have a product of a function v and a derivative of a function u, if you want to integrate that, the answer would be the product of function u and v, and minus the integral of the product of the function u and the derivative of function v. So in this instance, our u is going to be equal to negative cosine u, and what that means is that we do have 2 big bracket here, u cosine u, and then minus, so derivative of u with respect to u is going to be 1, and then cosine, negative cosine u. So this is 2 negative u cosine u plus the integral of cosine u, which is equals to negative 2 u cosine u plus, so when we differentiate sine u, we get cosine u. So sine u is going to be the answer there. However, we had said that u be equal to square root of x. So we can now say that the integral of sine over square root of x is equals to negative 2 square root of x cosine square root of x plus sine square root of x plus the integration constant c. And that, ladies and gentlemen, is our answer.